Hi, and welcome to this Now Maths Revise Now video. In this video, we'll be looking at solving linear simultaneous equations. In this video, we'll take a look at 4 different questions, including questions with positive and negative terms to eliminate, as well as a question with decimals. If you're only interested in some of these questions, you can use the chapters below to skip to the questions you want to see. If you're only just getting started with simultaneous equations, you might prefer to check out our in-depth video and come back here when you're ready. Now let's get started. So let's look at our first pair of simultaneous equations. The key to solving simultaneous equations is to make the numbers in front of either the x's or the y's the same. These numbers are called coefficients. We won't worry too much about whether they're positive or negative, and in this case everything we can see is positive anyway. To help us decide whether we're going to make the x coefficients or the y coefficients the same, we're going to use lowest common multiples to help us. So firstly, looking at the x coefficients, we have an x coefficient of 5 and an x coefficient of 3. The lowest common multiple of 5 and 3 is 15, because that's the lowest number that 5 and 3 both go into. Now looking at the y coefficients, we have a y coefficient of 3 and a y coefficient of 2. The lowest common multiple of 3 and 2 is 6, because that's the lowest number that 3 and 2 both go into. This tells us we could either make the x coefficients both into 15 or the y coefficients both into 6. Given that 6 is smaller than 15, I'm going to choose to make the y coefficient 6, because the smaller we keep our numbers, the less likely we are to make a mistake. So looking at our first equation, to make our 3y into 6y, we're going to have to multiply by 2. That means we're going to have to multiply the entire equation by 2. For our second equation, to make our 2y into 6y, we're going to have to multiply by 3. So the entire equation needs multiplying by 3. And as long as we multiply the entire equations, we won't change the solutions in the end. So we're going to start off by multiplying our first equation by 2. So 5x multiplied by 2 is 10x. Then 3y multiplied by 2 is 6y. And 34 multiplied by 2 is 68. Then our second equation, we're multiplying by 3. So 3x multiplied by 3 is 9x. Then 2y multiplied by 3 is 6y. And finally, 21 multiplied by 3 is 63. Now we have 2 equations with a 6y in each. So to eliminate this term, we're going to subtract the second equation from the first. So starting off with 10x subtract 9x, that gives us 1x or just x. Then 6y subtract 6y is 0, which I won't write down. Carry our equals sign down, and 68 subtract 63 is 5. So straight away this gives us that x must equal 5. Now we have our x value, we need to use this x value to find the correct value of y. And to do this, we have to substitute this value into one of the 2 equations that we started with. Usually, I would recommend substituting into the equation with the smallest numbers or the most positive numbers. In this case, the second equation is all positive and it has slightly smaller numbers. So we're going to write that we will substitute x equals 5 into our chosen equation, which is 3x plus 2y equals 21. Then when we substitute x for 5, 3x becomes 3 multiplied by 5, which is 15. And we have plus 2y equals 21. And we're left with an equation that we can now solve. So we have a positive 15, so we will subtract this from both sides. this will leave us with 2y on the left-hand side, and 21 subtract 15 is 6 on the right-hand side. And if we have 2y, we divide by 2 to find y. So we get y on the left, and 6 divided by 2 is 3 on the right. So we have a final solution that is x equals 5 and y equals 3. And at the end, it's really important that we write our solution as a pair. Now looking at our second pair of simultaneous equations, we're going to use lowest common multiples again to help us decide whether to make the x coefficients the same or make the y coefficients the same. So looking at the x coefficients first, we have an x coefficient of 3 and an x coefficient of 7. The lowest common multiple of 3 and 7 is 21 because that's the lowest number that 3 and 7 both go into. Now looking at the y coefficients, ignoring the fact that one of these numbers is negative and the other is positive for now, we have 4 and 2. The lowest common multiple of 4 and 2 is 4 because that's the lowest number that 4 and 2 both go into. So now we have the choice of either making the x coefficients both into 21 or the y coefficients both into 4. Given that 4 is lower than 21, I would choose to make the y coefficients 4. In this question, the great thing about making the coefficients into 4 is that in this first equation, we already have a coefficient of 4 or negative 4. So this first equation, we won't need to multiply at all. Looking at the second equation, currently we have a coefficient of 2. To make our coefficient of 2 into a coefficient of 4, we're going to have to multiply by 2. So we will have to multiply this second equation. So because we said we wouldn't need to multiply the first equation, I'm just going to rewrite that equation just underneath. And then multiplying our second equation by 2, we will have 7x multiplied by 2, which is 14x. Then 2y multiplied by 2, which is 4y. And finally, we'll have 47 multiplied by 2, which is 94. Now we have two equations with a y coefficient of 4 in each. However, one is negative and the other is positive. In this case, we're going to use the fact that if we add 4 to negative 4, we get 0. So we're going to add the two equations together this time. So starting off with the x terms, 3x add 14x is 17x. Then negative 4y add positive 4y is 0, which we don't write. We carry the equals sign. And 25 add 94 is 119. We're then left with a linear equation of 17x equals 19. So to solve for x, we divide by 17, which gives us x on the left, and 119 divided by 17 is 7. So we have an x solution of 7. When we've found our x solution, we now need to use this value to find the correct value of y. We're going to substitute into one of our original equations to do this, and I would recommend substituting into the equation with the smallest numbers or the most positive numbers. So in this case, I'm going to choose to substitute into the bottom equation where all of the numbers are positive. So we're substituting x equals 7 into 7x plus 2y equals 47. So replacing x with 7, 7x becomes 7 multiplied by 7, which is 49. And then we have add 2y equals 47. And now we have a linear equation that we're going to solve. We've got a positive 49, so we're going to subtract 49 from each side. And this will give us 2y on the left. And 47 subtract 49 is negative 2. Then we have 2y equals negative 2, so we divide by 2 to give us y on the left. And negative 2 divided by 2 is negative 1. So our final answer is x equals 7 and y equals -1, which we write down at the end. For our third pair of equations, we're going to start off in exactly the same way. So we're going to look at the lowest common multiples of the x coefficients and the lowest common multiple of the y coefficients. So for the x coefficients, we have 3 and 5, and the lowest common multiple of 3 and 5 is 15. Then looking at the lowest common multiples of the y coefficients, ignoring the fact they are both negative for now, the lowest common multiple of 5 and 2 is 10. This means that we could either write the x coefficients both as 15 or the y coefficients both as 10. Because 10 is smaller than 15, I'm going to choose to make the y coefficients both 10. So looking at our first equation, to make our 5y into 10y, we're going to have to multiply the equation by 2. And then looking at the second equation, to make our 2y into 10y, we're going to have to multiply by 5. So first starting off by multiplying the first equation by 2, 3x multiplied by 2 is 6x. Then -5y multiplied by 2 is -10y. And 22 multiplied by 2 is 44. Then for the second equation, we're multiplying by 5, so 5x multiplied by 5 is 25x. -2y multiplied by 5 is -10y. And 25 multiplied by 5 is 120. We now have two equations with a -10y in each, and we're going to use the fact that if we do -10y subtract -10y, that's the same as doing -10y add 10y, which gives us 0. So we're subtracting one equation from the other. Now, given that we have larger numbers in the bottom equation in comparison to the top equation, and we're subtracting, I'm actually going to choose to rewrite these equations in the opposite order. Now we have them written the other way around, we're going to subtract. So starting off with 25x subtract 6x, we get 19x. Then -10y subtract -10y is 0, so we don't write that down. And finally, 120 subtract 44 is 76. So we're left with an equation of 19x equals 76. So we solve by dividing by 19, which gives us x on the left, and 76 divided by 19 is 4. So we have an x solution of x equals 4. To work out our value of y, we need to substitute this value of x into one of the two equations that we started with. And this time there isn't too much difference between the two equations, all of the numbers are a similar size and they both have a negative term in them. I'm just going to choose to substitute into the first equation. So we're substituting x equals 4 into 3x subtract 5y equals 22. So x is being replaced with 4, so our 3x becomes 3 multiplied by 4, which is 12. And we have subtract 5y equals 22. And then to solve, we're going to subtract our positive 12. So on the left, we will end up with just -5y. And on the right, 22 subtract 12 is 10. Then we have -5y equals 10, so we divide by -5, which gives us just y on the left, and 10 divided by -5 is -2 on the right. So our final answer is x equals 4 and y equals -2. If you're struggling to figure out whether to add or subtract the two equations you have, if the coefficients you want to eliminate are both positive or both negative, subtract the equations. And if you have one positive and one negative coefficient that you want to eliminate, this is when you add the equations together. For our final question in this video, we're going to take a look at a question with some decimals in it. So we're going to start the question in the same way we have all of the previous questions by looking at lowest common multiples of the x coefficients and of the y coefficients. So starting off with the x coefficients, we have an x coefficient of 2 and 3, and 2 and 3 have a lowest common multiple of 6. Now looking at the y coefficients, we have a y coefficient of 5 and one of 7. Ignoring the fact that the 7 is negative, these two numbers have a lowest common multiple of 35. Now out of the two, the lower number is 6, so I'm going to choose to make both of the x coefficients into 6. So looking at the first equation, if we want to make our 2x into 6x, we're going to have to multiply the equation by 3. And looking at the second equation, to make our 3x into 6x, we're going to have to multiply this equation by 2. So looking at the first equation first, 2x multiplied by 3 is 6x. Then 5y multiplied by 3 is 15y. And 12.5 multiplied by 3 is 37.5. Now multiplying our second equation by 2, 3x multiplied by 2 is 6x. Negative 7y multiplied by 2 is negative 14y. And 11.5 multiplied by 2 is 23. Now we have two equations with a 6x in each, and because they are both positive, we subtract the second equation from the first. So starting off with 6x, subtract 6x is 0, so we don't write that down. Then 15y, subtract negative 14y. If we subtract a negative number, we add that number on. So 15y add 14y is 29y. And finally, 37.5 subtract 23 is 14.5. So we now have an equation of 29y equals 14.5. So we divide by 29 to give us y on the left, and on the right, 14.5 divided by 29 is 0.5 or a half. We're now going to use this value of y to find a value of x this time. So we need to substitute our value of y into one of the two equations that we first started with, and I'm going to choose to substitute into the top equation where all of the numbers are positive. So we're substituting y equals 0.5 into 2x plus 5y equals 12.5. So y is being replaced with 0.5, which gives us an equation of 2x. 5y becomes 5 multiplied by 0.5, so 2.5 equals 12.5. Then we solve, so we subtract the 2.5 from each side, which gives us 2x on the left, and 12.5 subtract 2.5 is 10 on the right. We now divide by 2, which gives us x on the left, and 10 divided by 2 is 5 on the right. So our final solution is that x equals 5 and y equals 0.5. Thank you so much for watching this Now Maths video. If you found this helpful, please like and subscribe if you can. And if you would like more help on this topic, please find our in-depth video linked below. See you next time.